Good day, grade 7 class. Today, we are addressing resource constraints in our technology classroom by looking directly at our immediate environment. We will learn about recycling and material processing using items often treated as waste. Let's jump right into this explainer and see how we can turn everyday trash into an absolute treasure trove of engineering tools. Now, look around. I know sometimes it feels like we need fancy, high-tech equipment to learn about technology, right? But what if I told you that our greatest classroom resource is actually sitting right in the trash bin? Yep, literally in the trash. We really don't need a massive budget to be brilliant designers. We just got to completely flip how we look at the materials around us. So the real question is, how exactly do we learn technology with a true zero-cost budget? Well, this right here brilliantly illustrates exactly what I mean. What we have is a functional toy car, but it's engineered almost entirely out of recycled Coca-Cola cans. I mean, how cool is that? This completely changes the game. It proves that with just a little bit of human ingenuity, we can transform discarded, everyday waste into fantastic, functional, technological projects. We're taking that old idea of reduce, reuse, recycle, and injecting it straight into active, hands-on engineering.
All right, let's move into Section 1, Plastic Problem to Planner.
Our first resource is the plastic PET bottles, collected right here from our schoolyard. Now, as technology learners, we need to analyze its physical properties. Think about it. It is incredibly lightweight, it's waterproof, it's flexible, and it's highly durable. From an engineering standpoint, those are absolutely amazing properties for design. But here's the catch. What makes plastic so incredibly great for engineering also makes it a massive hazard. Discarded plastic poses serious environmental concerns precisely because it is non-biodegradable. When it gets tossed away, it doesn't just disappear. It just sits there in our environment, causing a whole lot of harm. So the challenge for us is, how do we harness those positive properties while counteracting its negative impact? Simple. We recycle.
In our lesson, we actually recycle these bottles by cutting and reshaping them into self-watering seedling planters or even storage containers. By applying basic plastic joining and cutting techniques, we do all of this without needing any costly equipment whatsoever. We're quite literally solving a real-world need using totally free resources.
Moving right along to Section 2, Cardboard, the Hidden Strength. Our second free resource is corrugated cardboard, rescued directly from discarded grocery boxes. I want you to take a really close look at the cross-section of a piece of cardboard. Notice how it consists of two flat outer sheets with a fluted zigzag sheet glued right in between them? That zigzag layer isn't just random. It is an absolute marvel of structural design. It's not just basic packaging, it's incredibly smart engineering. Because of that internal fluted structure, corrugated cardboard has some mind-blowing properties. This structure provides high compressive strength while staying incredibly lightweight. Plus, and this is a big bonus for us in the classroom, unlike heavy woods or metals, it is wonderfully easy to cut and laminate using just regular scissors, craft knives, and standard glue. So, how exactly do we put this to use? In our practical activity, we will cut and glue these cardboard sheets into laminated layers to create strong, structural storage trays for our own classroom. Think about that for a second. Suddenly, a totally discarded grocery box becomes a vital, load-bearing piece of furniture. Talk about a glow-up. Which brings us to Section 3, Connecting the Dots, Materials and Needs. So we've got two very different waste materials being used to solve two very different classroom problems. This perfectly illustrates the concept of fitness for purpose. As designers, we must select materials based on their unique physical properties. We specifically chose plastic for the planters because it's waterproof and flexible. Conversely, we went with cardboard for the storage trays because of its fantastic compressive strength and stiffness. The bottom line here is that the nature of the product always dictates the material we select. And now, Section 4, the design process, systematic solutions. Everything we are doing today is directly tied to our CAPS curriculum requirements, specifically learning how to systematically solve problems using the design process. Transforming literal trash into functional trays and planters allows us to perfectly practice every single step of this cycle. First, we investigate physical properties. Then, we design a solution. Next, we actually make the product. After that, we evaluate if it actually works the way we intended. And finally, we communicate our findings. It's a brilliant, cyclical process that works every single time. To sum it all up, recycling these everyday materials helps us practice essential design process skills, care for our environment, and build functional items at absolutely zero cost. Human ingenuity and a solid understanding of structural and material properties will always overcome a lack of physical resources. You really don't need a high-tech lab to be an amazing engineer. You just need your mind and the design process.
So, I want to leave you with this final, provocative thought. The next time you go to throw something in the recycling bin, just stop for a second. Look closely at its properties. Is it flexible? Does it have compressive strength? Look around your home right now. What piece of everyday trash will you engineer into your next great invention? The resources are literally all around us, class. Now it is completely up to you to design the future. Thanks for hanging out with me on this explainer, and get ready to start building.